How large is a pairs? To understand how a parsec is defined, you should first know what an astronomical unit, AU, is. 1 AU is essentially the average distance between the Sun and the Earth, approximately 150 million km. 3 times winner of the OWLD lockpicking championship. I'll have the country's largest collection of skeleton tunkeys, and I'm still getting nowhere new for Moof Van Moof. So a parsec is defined as the longest length of a triangle whose shortest chyle is 1 AU and which subtends an angled 1 arcsecond at the opposite vertex. LGU calculate for 30. You will see that 1 partic equals 3.26 light years, or the distance light travels in 1 year, which is about 9,460,000,000,000 kilometers. Here, we are talking about 28 gigs parsecs here, which is 93 billion light years, that is, 879,780 times 10 raised to the power of 18 kilometers. That is just unimaginably huge. For comparison, the length of DNA of all humans on Earth combined together, when stretched, will be about 0 billion light years long. Now, look at the figures mentioned earlier carefully, and you will discover that something looks inconsistent. The speed of light is the absolute maximum speed possible, right? So, if the universe is 13.7 billion years old, how come the width of the universe is about 93 billion light years? Technically, if an object after the Big Bang mores worked with the speed of light, it should been traveled a maximum of, what, 13.7 billion light years, nothing more, nothing less. From where did all the matter come? From beyond this limit. This is where we turn to Hubble's law. The law states that objects observed in deep space are found to be redshift. RECL shift refers to the shedding of the wavelength of light to the red end of the spectrum, that is, increase in the wavelength of light. But why does the wavelength X land? One reason. Space is expanding. And this is not just that objects are moving away from one another, but the fabric of space itself is expanding. Here is where everything goes crazy. The expansion accelerating. H's ask you mad that dark matter and dark energy have a strong influence on this behavior, so the extra distance due to the expansion of space needs to be taken into account when estimating the width of the universe. Why the edge of the universe clearly not at some 13 billion light years from Earth, it is estimated to be much beyond that. What is farthest astronomical object humans can see? One thing is there are some objects in the universe that we might never see. Why? About 16 billion light years from Earth. This marks the current cosmic event horizon of the universe. Are we there yet? Nope, not yet. This distance is the upper limit of light ever reaching us. If it originated at that distance today, this implies, beyond 16 billion light years, the expansion of space is faster, the speed of light itself. Obviously, the light will never reach us, as it will have to travel through a relatively expanding space. This also signifies that any errant that may never appear today, beyond the cosmic event horizon, will not be observable by us, no matter what. But we can see even further through GH telescopes like the JWST. The most distant galaxy even observed is the GNZLL, located about 32 billion light years away from Earth. Mind you, we calculate this distance taking into account the expansion of space VWELL. At about billion light years from Earth, we reach what is called the surface of lost scattering. That is what you will observe irrespective of the direction you look at. The surface of lost scattering is like a uniform sphere of fog from which the first even photos of cosmic microwave band kg round radiation come after recognition and photon decoupling contribute to the name. It is the origin of the very first scattering of light, but the last of what we can observe. LS this finally the edge of the universe. Eyes and a technically, this is the furthest point in space and the farthest in time that we can observe, that essentially forms the edge of the observable universe. What lies even beyond that is what is known as the opaque universe. This marksth limit of what we can observe but not what we can imagine. Let us now go even beyond the edge of the observable universe. What can exist there? All this time, we have only explored what existed at a point space in the distant past. A more unimaginable question would be, what could possibly exist there at present? The edge of the observable universe also make what is called the particle horizon, the maximum distance one see into the past. Everything you have seen so far was from the perspective of keeping Earth at the counter and scaling time to the past with distance. This brings us to the question: is the universe infinite? Well, from Einstein's theory of relativity, it can be estimated directly that if the universe must be infinite, can we then conclude there is no edge, is on edge or end to the universe? LT is hot straightforward. We have not been able to determine categorically if the universe is fine or not. Let's hear what you think of the universe in the comments section.